vertical curves, but we are now going to be adding another dimension to it. We're going to be talking about vertical curves with respect to stopping sight distances. So far, all I've given you in most of our examples was, let's just say, two tangents, a curve. We had PVI here, we've had PVT here, and PVC here. And what I've been giving you so far was the length from PVC to PVT. However, that length had to come from somewhere. That length had to be determined. And so what we're going to be doing now is determining the length, or the minimum length, that is required for a certain speed. Therefore, a certain stopping sight distance. Well, why? Well, we want to make sure that this length is sufficient enough for any vehicle that's traveling on the road to be able to stop and not be obstructed by any sight lines, or any their sight line not be obstructed by anything. So that length does have its limits, and the only way you can figure out what that length is for a certain speed is to design your vertical curve with respect to a stopping sight distance. Well, if you turn to your slides, you should see a slide that looks something like this. And on this slide, it shows you the schematics of a vehicle traveling on a crest curve. Now, I want to point your attention to a couple of things on this slide here. The first one is the fact that you can see that the sight line is drawn. And that sight line basically continues all the way until it reaches an object. Okay? So you have H2 and H1 being shown there. And those two items are in reference to two heights. Let's just start with H1. H1 is, if you remember, the eye height of a person driving a vehicle that we assume to be 3.5. H2 is what we are referring to as an object height. Basically anything less than 2 feet, we need not pay too much attention to, at least for a vehicle traveling on the road. So when we actually look at these two heights and the fact that they are connected to an actual sight line, we can see how the stopping sight distance plays a role in determining the entire length of a vertical curve or crest curve. Okay, well, how do we use that? What is the length? Well, the length is determined, the length, this right here, what we're referring to as LM, or you can also look at it as being saying as the minimum length required for a certain stopping sight distance, is equal to these two equations down here. Well, here's how this works. This is the L-min equation. This is one of them. And here is the other L-min equation. Okay? Which one you use really determines on which one of those equations satisfies the conditions on the road. What do I mean? Well, the conditions on the roadway that I'm referring to is the stopping sight distance in this relation to the length. And that is what you see right here. This S is basically the stopping sight distance. And this L is referred to, or is in reference to the length of the roadway. All right, same thing with this one down here. You have your stopping sight distance and the length of the roadway. Oops, I got it backwards. Okay, so you have these two conditions, and only one of them can be met. Because if you notice, The greater than sign is pointing towards the stopping sight distance in this equation, and the less than sign is pointing to the stopping sight distance for this equation. Yes, I did say for this equation and that equation because those two equations are equal to the ones that we've already mentioned. How are they simplified? Well, this equation is the same as this equation here, except the only thing that we've done is we've placed the 3.5 here and the 2 feet here, and we've pretty much condensed the equation to looking like this. Same thing goes for the equation down here. We simply put 3.5 here and the 2 feet here, and we've condensed the equation to this one. Therefore, you have two possible equations that you can use, and here they are, assuming that your eye height that you're referencing does not change, and of course the object height that you are concerned about does not change. All right? So you'll use this equation if the stopping sight distance that you calculate for that road is greater than the length, or you use this equation, L min, that is found from this equation, if the stopping sight distance is less than the length. Now some of you may be thinking, okay, well, how do you figure out the length? Well, this length here is LM, and this length here is LM, the minimum length. So what that means is that you're going to actually have to calculate both of these and see which one of the conditions are met and pick the condition, or pick the minimum length that satisfies the condition. Well, let's look at this with respect to an example. Now, this example that I'm going to draw is one of a crest curve. But before I continue on with this example, I want to show you that the sag curve has its own set of equations. All right? So you see, here's the sag curve, and we've had a crest curve already. So we've gone through everything for crest curve. Now I want to show you that the sag curves have a little bit of change in their equations. However, the same still applies. You use this equation if this is satisfied. You use this equation if that is satisfied. You have to calculate them both out to determine which one. Now,